Recording is on.
Perfect. Thank you for joining us to the evening of Python coding. Starts the 7th year. Hopefully we'll finish this 7th year of evening of Python coding. We'll see how it happens. But thank you for some of you that's been here for several years now. I'm not sure how many more of those we'll have, but thank you for all being here. And today we have a very special presentation that involves several libraries, more than one. We have pcluster, we have Jupyter Lab, and we have Dask. Again, all combined together in this presentation to show us how we launch things on the cloud as a cluster, many workers. And to present this, we have two presenters today, Ramon Ramirez and Aaron Shkolnik. They are both from a company called Navteca. I hope I pronounce everything right. And I will let Ramon take it from here. So Ramon, go ahead and take the presentation from here. Thank you.
Okay. Thank you, Jacob. Hello, everybody. My name is Ramon Ramirez, like Jacob was saying. I'm the co-founder and CTO of Navteca, which is a small business that focuses primarily on science. So we are working primarily with NASA and NOAA. And what we want to present today is this concept of trying to centralize different technologies through the Jupyter Hub and Jupyter Lab Interface. What then is going to show you is from Jupyter Lab, we're providing the scientists a mechanism to launch a Dask cluster to do, NumPy and Panda are in parallel. And also machine learning. You can also launch traditional HPC clusters in the cloud. And then we're not going to present this today, but we have a Jupyter Lab extension that we're working on where you're going to be able to directly from your notebook, you're going to be able to launch clusters of functions as a service of AWS Lambda. Aaron, you want to take it from here?
Sure. Again, my name is Aaron Shkolnik. I'm a cloud solutions architect. Again, Navteca is the name of the company that Ramon and I are with. And my primary day job is working with the NASA Center for Climate Simulation at the Goddard Space Flight Center in Maryland. And what I'm going to show you today is a three-pronged attack, as Jacob was kind of getting at, showing you first of all, how we have our Jupyter Lab interface set up, but largely how you would then use the Dask gateway on top of that to run a parallel job across multiple worker nodes. So I can, without any further adu, I may as well share my screen so you guys can actually see what I'm working on rather than me just talking about it. So give me 1 second here, and we'll go here to our Jupyter Lab interface. Now, again, folks that are brand new to Python may not be familiar with Jupyter Notebooks as a concept, but indulge me for those who are familiar with it.
Alan, I have a request. Can you make the font bigger?
I can, yes. So there you go. Yep, we can make the font bigger. Although I can't make my sidebar smaller, unfortunately. So
no, that's perfect. Yeah. I just want to make sure that the recording catches the
Absolutely. Did we just lose Jacob there?
I think you put yourself in mute.
There Jacob. We go. Okay. Now, yeah, he muted himself. That's fine. All right. I just wanted to make sure his network dropped off. And yeah, I know, Silas. I tried, and then actually this one's got a fixed width on this one, so I can't move it over. Anyway, Jupyter Notebooks, for those who aren't familiar, and again, indulge me for just a moment. For those who absolutely have played with Jupyter Notebooks before. It's just a great way to do interactive programming. You basically have an interactive interpreter. And in this case, we are using a Python kernel. We can run any number of programming languages in here. We actually, we have many scientists that want to use Fortran still. I kid you not. A lot of the computational and dynamical models that they use are built in Fortran. So we can run Fortran code right here in the browser for them to test their code. But in this case, again, we're going to use Python. And the nice thing about Jupyter Notebooks is that you can share them out, and you can build markup or markdown right into your code. So you've got a code block here, but you've got markdown in between that actually explains what's going on, rather than just the inline comments like I have here. And what I'm going to show is how to do some work using Dask Gateway. And I'm going to back up a half a second because I talked about Jupyter Notebooks, but I also want to talk about Jupyter Hub, and I want to talk about Dask Gateway. So again, it's a three-layered animal here. The Jupyter Notebook is what you put your code in, right? That's what you're seeing here. This particular file, it's a file, an IPY NB, or Interactive Python Notebook is what that stands for. Jupyter Hub is kind of like an enterprise implementation that allows multiple users to be on a hosted system and all run Jupyter Notebooks on the same system. And in our case, we have it set up in a Kubernetes environment, so it's a little more flexible for us. So each user ends up in their own container, and you can go down a rabbit hole if you want to talk about containerization technology. That's a completely different talk for another day, but I just kind of want to give you a lay of the land. On top of that, we have something called Dask Gateway, and Dask Gateway, what it really does is an orchestration. It does orchestration for an actual cluster underneath your work. So I can spin up a cluster, and I'll show you how that's done right here. I'm actually importing the Dask Gateway library and creating a gateway and actually doing some cluster options. And in this case, I'm actually setting some defaults, but it actually gives me a widget I could set those here. And what I'm going to do here is I'm going to set each worker to run 2 cores. Each worker is going to get assigned 1 GB of memory, or 1 gigabyte if you want to be technical. And then what Docker image that is going to run. And in this case, it's actually going to run the same Docker image that the Jupyter interface is running in. So here what I've done is now I've created a cluster with that. And when I tell it to do that, it creates all of the underlying architecture without any additional code. And I'm allowed now to scale that cluster either in an adaptive way or in a manual way. And I actually scaled this out to 4 workers, but right now I'm going to scale it back down to 1. Okay, so now I have 1 worker with 2 cores. And one of the nice things that Dask Gateway does is it gives you an actual dashboard that you can look at. And it can show you things like your workers. So here's my one.
Aaron, you're trying to cram too much.
Yeah, you're going to.
Slowly explain to the people what the worker is, what it does.
Yep. Okay. Yeah. So what a worker is a process. It's just like any other process that you would run on a machine that's going to do your work for you, right? So Dask as a library, for those who don't use Dask is a parallel processing library. And so what it does is takes your code and breaks it into smaller chunks that can be run in parallel to increase the speed of your code and to actually make it return in a more efficient manner. Okay.
Just very briefly, Aaron, and for those of you that are not familiar with Dask, but are familiar with Panda and NumPy, Dask creates a wrapper around those 2 libraries. And if you know how to work with any of those 2 libraries, you will be able to use Dask to do parallel NumPy and parallel Panda with basically 0 learning curve.
Right, and also Xarray and other libraries that again that are built right into that. It really is a drop-in. Dask is a drop-in add-on for all of that process. So again, a worker is just another process that is going to take a piece of your processing. Okay. Again, what I've done here is I've created, because we're doing this on Dask Gateway, we're actually creating a cluster of workers behind it. So it can actually run on separate hardware. Depending on how many workers you need, it may run on additional hardware. And because we're running in AWS, that can be infinitely scalable, right? If I needed 1,000 workers, I could tell it, give me 1,000 workers. Now, I'm not going to do that today because obviously we don't need 1,000 workers for the work we're about to do. But what I'd like to show you quickly, again, I'm going to have the UI open. And Ramon, what I might actually, since I got the font big, I may just switch back and forth between the windows. I can actually bring some of these things in directly into the interface over here. We've got a nice plugin that allows you to do that. But what we're going to do is we're going to do some work here. And this is very basic. I'm just doing some math. I'm creating an array of 30,000 by 30,000 random numbers. So I'm creating a Dask array with random numbers, and in 1,000 number chunks. And I'm going to compute the mean of that array. it's meaningless work, but it's good computational time, right? So I'm going to go ahead and run this cell with one worker. You see, I've got one worker available to me. So again, I'm going to run this cell, and it's going to chug away. And over here and we actually should start seeing that work start, and I haven't seen it start yet. I'm not used to seeing that.
It happens. Don't worry.
It's live demo. It's live demo at its best.
Don't worry. It's like we're having many things like this. If needed, you have to restart something or whatever. Do it. It's okay.
You are not seeing in the user interface, Aaron?
Yeah, I'm not seeing the workers either. So I wonder if
you can restart things.
Timed out. Yeah, I wonder if the cluster timed out while it was waiting for me to send it some work. Yeah, that's what happened. The cluster timed out while it was waiting for work. So what happens? One of these things, we have it configured such that it will turn itself off if you're not using it, because you don't want a bunch of resources sitting underneath. So give me 1 second. It's going to actually, it's going to go ahead and reset here.
While we're waiting for the reset, so you're showing us the gateway, and you're showing us the notebook that already gets the gateway and also cluster, but you're telling us the cluster timed out, so it's actually something that's happening somewhere else. Can you tell us while we're waiting, where does it start? Like what?
Oh, that's why.
your notebook.
My notebook crashed. Okay.
So yes, so Jacob, so in our case, because we want to be able to scale, your screen just went off.
I know.
That's okay. He doesn't need to share this. We'll wait until it works. While we're waiting, let's.
Okay. So in our case, because the project with NASA is for us to have this Jupyter Lab as a centralized interface for different type of clusters, we use a type of Jupyter Hub that is scale. It's multi-user. It's like Jupyter Notebooks, but multi-users, and it is more suited for enterprise. It can scale basically unlimited, depending on the resources that you have. So the infrastructure that is supporting the Dask cluster that Aaron is going to show you is Kubernetes, which is a container orchestrator. Now, there are two types of Dask. Dask is a library that allows you to do parallel Panda, parallel NumPy, and some machine learning flavors. The Dask that we use is not the regular Dask. We use Dask, what is called Dask Gateway, which is kind of like, it has the same features that a regular Dask, but it has a more enterprise set of features, right? It's still open source and free, but it gives you the logs, so you see who is launching clusters and things like that. So that's what we need to use on NASA.
That's okay. You're talking about the module within Dask called Dask Gateway, but it has to sit on top of something. You're saying in your case it sits on top of Kubernetes?
That's correct. It sits on top of Kubernetes, and Kubernetes sits on top of AWS. So on AWS, we have multiple instances, multiple machines, and you can deploy this also on a traditional data center. You can deploy Kubernetes even on a cluster of Raspberry Pis, actually, which is very interesting. But we have multiple nodes, multiple computers, and those computers run Kubernetes. Kubernetes is a containers orchestrator. So each node is going to have a set of containers. So the way it works is when Aaron launches a new Dask cluster, if it has enough power on the nodes to host the container, it's just going to use the EC2s that are running, the machines that are running. But if it needs more machines because it doesn't have enough memory or CPU, it will actually automatically launch another EC2 instance to place those containers.
Okay, so this is how you configured your Kubernetes to allow you to do this, and all Dask Gateway does the the scheduling of more instances, or the request for more instances?
That's gateway talk to Kubernetes, and Kubernetes talk to AWS.
So you have to install. You have to install. First of all, you have to have AWS credentials. The second thing is you have to install Kubernetes somehow. Correct?
Yes.
Okay. So and then you are able to put on top DAS gateway. This is the order of things. Thank you.
Yes. Now, just one thing that I wanted to mention, because it looks like a lot of technology stack, a large technology stack. We're building this for NASA, and we have all these orchestrated, what is called infrastructure as code. So we are able to deploy this DAS gateway and Jupyter Lab system.
Someone is not muted. Probably some of the newer people who joined. Correct? Hello? Can everyone presenters mute themselves?
Sanja, can you mute yourself?
Who is that?
Sanja.
I don't see that. I see everyone's muted.
Sanja.
SG, yeah, okay. Let's see if I can mute.
Yeah, you can say.
I'm not sure, but oh, okay.
You did.
I'm not sure.
Yeah.
Okay, that's better. Sorry, guys. But new system. We're still studying all of these.
What I was mentioning real quick. Sorry, Aaron. Just
go ahead.
To finalize, we have built all of this infrastructure, what is called infrastructure as code. So we have the code to launch it, and usually it takes like half an hour for us to configure the whole thing. And if anybody's interested, we can show them how to on a different meetup. We can show how to deploy the whole infrastructure. It's not that complicated.
Ouch! You have a very This is something I think many people will be interested in. But for now, let's continue. We don't want the server to lapse again.
Yeah. So I know what happened, Ramon, is the spot instance got taken that I was on. So okay. that's what happened. Anyway, so again, I've got this. I'm back to where we started with one worker. I can actually see that worker exists, which is good. And now again, I'm going to give it some work. Okay. So we're going to have it compute that 30 by 30, 30,000 by 30,000 number. It's got 2 cores, so you can see the 2 tasks running in parallel, and it's almost complete here. And this is just a good graphical representation of what's going on in the background. And it'll tell me when it's done, and that means it's done, and I have a result here. And this is actually the actual result of the random numbers, but it took 17.5 seconds to do that. So let me go ahead and scale that up. Let's go scale up to 2 workers just for grins. I should have enough underlying hardware to do that without waiting. There we go.
2 workers will actually spin it up on more cores, correct? It's
yep.
Like
so each worker has 2 cores assigned to it. That's what we set up here. So now I have 2 workers and 4 cores and just over 2 gigs of RAM available to the process now. And again, if I run that same bit of code, and you'll actually see now that it's running 4 processes in parallel, and you see it's running a little snappier than it was before, right? So again, it took about 17.5 seconds before. We now completed that work in 12.
And Jacob, one thing that I wanted to mention, Jacob and the rest, one thing that I wanted to mention is you can do the same with Dask and try to do the orchestration yourself. You can try to deploy the Dask worker somewhere and the Dask master on a different node. But as you can see, with this interface, it's so much easier for the users to launch clusters and to add nodes, to add workers.
Right, and so just for grins, I'll go ahead and scale up to a 3rd worker. I think I had it at 4 before, but I don't want to have it wait around if it doesn't have enough resources available and having to spend more resources. So we've got 3 workers and 6 cores, and again, I'll run the same code as before. You'll see now that instead of 4, it's running now 6 processes, because those are the number of cores that we have available to it, and it should finish. It doesn't scale in a linear way. It scales in an exponent in a kind of close to linear, but not. Again, it's about 12 seconds to finish that work. The other and again, we can certainly go loop back around and go through questions about that, but I'm going to go ahead and shut this cluster down for now. Again, so we're not having resources out there that don't need to be running. Unfortunately, I lost my terminal windows that I had open before, and now hopefully that it's in my, okay, let's see if my other terminal window gives me my other history.
You can disconnect, set them up, and while we talk about something else, you can stop sharing your screen for a second and set them up and come back, and we'll fill up for you.
Yes.
Well, one of the thing I can show you real quick is I kind of want to move into the whole parallel cluster discussion. And explain what parallel cluster is for folks that were familiar with star cluster and other HPC orchestration stuff. And so Ramon, you can take a second to talk about that briefly, and then I can show you what I did to actually get it set up and get a test cluster running.
Okay. Yes. So. A few years ago, this was like, I would say 10 years ago, I got involved I was working on different HPC projects. And as I said before, one of the customers wanted to try this HPC work on the cloud because of the time that the project was going to last. At that point, we started using Star Cluster, because it was the only kit in the block. So it was the only thing that we could find that does the orchestration in a very easy way. And I was using that for a while, and it was actually, it works pretty well. But then AWS decided that there's a lot of people with this need, and they came up with this Python library that is called Parallel Cluster. And I say Python library because you can, like, Aaron's gonna demo it, but you can. It's easy. It's so easy to install it as doing pip install, or I think it's also available in Conda. So it's a Python library, and it basically help you orchestrate HPC clusters in AWS to the point that it configures many of the values for you. But also it install your any flavor of queuing system like Slurm or SGI, or what is the other one? Batch, and what is the other one? PBS.
Slurm, Torque, SGE, and AWS Batch.
Right, exactly. So we have been we transitioned from Star Cluster to P Cluster, and they keep adding features. They make it very, very easy for the scientists they can start running with a cluster, basically with a few commands and a configuration file, which is what Aaron is going to show you. Yep. Our goal is to centralize launching these HPC clusters also from the notebook. Because again, we want to centralize everything through a single authentication mechanism.
All right, so that's a good that got me enough time to get things started again. So that's a good job. Let me share this out. Give me 1 second here, and we'll flip back over to that window. And I want to show you briefly how we would set up a cluster in AWS. Now, this particular, I'm still running in my Jupyter Lab environment. My particular Jupyter Lab environment has the proper AWS permissions to create resources in the environment. You could do this from any EC2 instance, assuming you assign the proper permissions to it to create new resources in the environment. So all I have to do to get that library is pip install the AWS Parallel Cluster library, which I've already done on this machine.
This is beyond. This is, you don't install Boto or whatever. AWS usually you install Boto, and then everything kind of comes with it.
Right. Well, the AWS CLI would install Boto with it. AWS Parallel Cluster probably has a dependency for Boto as well.
Yes.
Okay. So it would install it on its own, because it does make calls to the API, obviously. So it's going to use Boto 3 as its underlying mechanism to actually make that work. But pcluster does some nice things, and actually the first time you run it, you do pcluster configure, and I can't overwrite my bare config, but what it does is actually creates a configuration file for you, and let me cat it real quick. And so what it does, it asks you a bunch of questions. It actually will step you through, and you end up with this nice configuration file at the end SSH key do I want to use to access the instance? What kind of instance type do I want for the master and for the compute machines? In this case, I just let it default to T2 Micro because we're not doing anything exciting. So we're going to use the base instances. What subnets you want your machines to live in, and so on and so forth. Right. So that's the and it steps you through all of those things. And like I said, I could delete this config and show you to that, but I don't want to do that just yet. But then it creates, when you tell it to do pcluster create, it then will create based on this config file. And what I have ended up with is a cluster. We call it a head node now. We don't use the master slave nomenclature for that anymore. So it creates a head node.
So it doesn't create a real cluster. It creates only one node.
Well, it depends. It depends on how you have it configured. In my case, in my config file, I didn't tell it. Okay, because I set 0 and 10. I set its defaults. The defaults are 0 nodes at the beginning, and it will scale up from 0. So you could tell it that you only want you can tell it to start with 0 nodes, but set a maximum of say 10.
Okay.
Right? And it will only create the nodes when you actually call for them. So again, I'm using Slurm on this. So people who are not familiar with Slurm, just roll with me here. You'll notice that I have a partition called compute, and that I have 10 nodes available. 4 of them are actually idle and ready. Okay, 6 of them idle with this little sign means that they actually haven't been started. So if you actually, I can show you in the AWS console, when I flip over there, I have these 4 compute nodes right here, these 4 guys right here that are up and running and ready. Because I had actually submitted a job that asked for 4 nodes a few minutes ago.
And yes, I think it would be interesting, Aaron, to explain how AWS approach to when it launched the compute node, because the compute nodes don't get launched from the beginning. It only gets launched at some point, right?
You can specify that behavior. There are use cases for people who want to have.
But you want to explain the 2 cases, the two approaches.
Right. So in some cases, you would want to set it so that your compute nodes come up immediately upon the creation of the cluster. That would be ideal for people who are submitting jobs that are going to run constantly. Right. You're gonna keep your cluster saturated. In our case, the compute nodes are only going to come up when I submit it work. So I have a test job here that I submit to Slurm, and I'm telling it I want 4 nodes and I want 1 task per node. And the reason I only want 1 task per node is because the T2 Micro that I have as the compute instance only has 1 CPU available to it. And then I'm telling it here to run 4 processes in parallel using MPI. And that's a message passing interface. If you're not familiar with HPC, is just a typical way that these processes are launched using OpenMPI. Intel also has an implementation of that, and so on and so forth. So if I take this job and say sbatch test.j, it's submitted batch job 10. So let's see if it's in the queue. It's actually already finished because the 4 nodes that I asked for are already running. So you'll see I have job output for job number 10. So job out 10, you'll see that it actually ran on 4 different pieces of hardware, because all I'm asking it to do, I'm asking it just to run bin hostname. Right? This could be any arbitrary piece of code. It could be Python. It could be in any programming language you want. It could be in C. But in this case, I just asked it to return to me the host name that it's running on, and you can see that it's running on 4 different hosts here. And that's what. Again, that's just this is like a hello world version of an MPI job that can be run on a cluster.
Okay, I have a few questions. Those are like personal. I'm already confused because, like you said, that pcluster can launch multiple types of cluster. SGE, you said SGE, Slurm, Torque, PBS, and so on. You said all of those like something that's already built in. Now, usually when you span the cluster, you have you also have to configure some shared folder that everyone is like NFS, all the compute nodes are using it. How do you do those things in pcluster? Is it part of the configuration file? And how do you tell them, do I use Slurm or SGE or none of these, or does them
All of the above. Those are all good questions, and they are all answered in the configuration file. This is a very basic config that I used. I used all defaults. I'm pretty sure if I go here, there's a folder called shared that gets created by default, and that does the NFS. So all of the nodes have access to that folder.
But Jacob, one important thing to keep in mind, as Aaron was saying, Peak Cluster has, if you look at the documentation, it has hundreds of options. So you can deploy, you can share, you can deploy, for instance, Gluster, or you can share an NFS system. You can also, one thing that we usually do is on our configuration file, we define more than one type of clusters. Because sometimes you want a type of cluster that you're going to use Slurm. Or sometimes you want a type of cluster where the compute nodes are going to be one type. And then you have define another cluster where the compute nodes are going to be different types, right?
I can show you an example of that. But what I pulled up here is the configuration guide for parallel cluster, and it is extensive. It is a very extensive guide on how it works, right? So
on the options, what we do usually is if I want to deploy NFS, for instance, connect NFS to this, you just go search NFS on the guide and it tells you how to do it.
Well, there's two flavors. There's the managed EFS, which is Amazon's NFS implementation, but then there's also a default NFS that is already just included as part of the deployment. That's what that shared folder is.
What's the difference between the EFS and the NFS? You go into details, or is it?
EFS, for example, is available outside of the cluster. I can create an EFS implementation as shared storage, and in this case, I actually have. Do I have EFS in this particular Dask Hub? I think I do. Yeah, so I have a folder here called EFS on our Dask Hub, and this is actually shared storage, and I could mount this into the cluster if I wanted to.
Into the cluster, into your machine, anywhere you want. It's just a managed NFS that you don't have to worry about the underlying hardware.
Yeah, right. Very nice.
Yeah, and it's not particularly expensive. The performance is okay depending on how you configure it. Again, with all things AWS, it's all a matter of configuring it in the proper way to get the desired result. Yeah, and Ramon was talking about you can go kind of overboard and do FSX, which is their high performance implementation for service. It's FSX for Lustre is what they call that. And one of the things that I uploaded into GitHub in the link that's in the invite for tonight, I did upload my notebook to show you Dask Gateway, but I also put in a parallel cluster configuration, and this is one on a much more complex cluster that we have that shows you some of the things that you can actually have in the config file. So again, you talked about what scheduler is being used. That's in the cluster. That's in the cluster config. So we're telling it to use Slurm. What is in this particular instance? The master is a C5 extra large, and it has we have some EBS volumes, some block device storage attached to it. We have an FSX Lustre attached to it. We have an S3 bucket that has read-write access to it. And you can assign additional IAM policies, post-install scripts, all sorts of fun stuff. But then here you can see we have a queue called HPC demand and a queue called HPC spot. So that creates two different partitions in parallel cluster in Slurm that you can submit jobs to. And so if you need something that's going to run right now and isn't going to be interrupted by AWS because you have it on a spot instance, and so you want on demand, you can send jobs to this on demand cluster. We say that this spot is the default because we want the workload to be less costly. But again, you can create multiple different compute groups here, and then again it shows the FSX where it gets shared out and custom EBS volumes that you can attach to the cluster itself. So like I said, you can do a lot, and the documentation is extensive, and AWS support is helpful with that too. They have experts that can help get you where you need to go, and we can help you with it. If there's just an offhand question that you might.
Oh, guys, this is wonderful. Thank you very much. And like I'm seeing this. I'm amazed. A few years ago, like it was like it was a dream. Now
Yeah.
it's more than reality. Now it's much more than you ever wanted. And now let's connect it to dusk. It's like if I want to run a dusk schedule, can it come immediately ready for dusk or not? Or do I have to do the dusk SSH or dusk the gateway on top of it?
Well, you could. I don't know if you want to answer, Aaron, or you want me to
No,
answer.
I'll let you field that one.
Yeah, you know, with Dask, you can configure Dask, the Dask worker and the Dask scheduler. If you want the compute instances to be already configured with Dask, you can send configuration to the workers. I'm sorry, to the compute instances at boot time. So let's say that you're going to launch a big cluster with compute nodes, but you want something to happen on those compute nodes when they boot. So you can launch the installation of Dask and configure the workers. You can also, if you don't want to use that on at boot time, you can also configure an instance to be your, with all the Dask configuration that you need, and then use that instance, use that AMI, turn that instance into a template, into an AMI, and use that AMI to be your compute node.
So you actually can tell pcluster use that instance that already has all the things installed properly.
Yep. Yes.
Use and this is the one that you're going to use. And an AMI for all the beginners is Amazon machine image.
Exactly.
Basically, it's the hard drive copy of how the machine should look like.
Exactly, and you can bake it. We say you can bake everything that you need on an instance, turn it into an AMI, into one of those machine template, and then use that template to launch your cluster. So in that way, if you have, for instance, Python code that you want already to be automatically in the compute node, you could even bake it in the compute node, in the image, and then use that as your compute image.
And one of the things that I know some of the HPC groups are doing is instead of baking in a custom AMI, they're using SPAC and SPAC modules as a runtime way to configure your compute nodes. So there's again, as I said before, as with anything in AWS, there's about 9,000 different ways to get from point A to point B. So.
Yeah. Okay, we have a mute problem again. Okay. Someone needs to mute. Okay. SG, can you mute? Can you please mute? Okay. Yeah, okay. This is one thing in the system. It doesn't allow it. Let's see if, oh yeah, I can think.
You're the host, Jacob. You should be able to do anything.
I'm not sure. I think so. Is it correct? I'm not sure. I can. I'm trying.
Sanja.
Press the button probably. It's something that it's a new system, so it's still something that
Sanja G, you're unmuted. You need to mute your audio.
It's like we were, Ramon, you were able to mute me, but I don't know why, and you muted yourself now. So I don't know. This one person we can't mute for whatever reason.
Yeah, that's strange.
The joys of live web meetings. We've been doing this every day for what, a year and a half now. So, and you're muted too, Jacob.
Oh, okay. I was muting myself apparently. It's maybe a bug in the system because I pressed the mute there, so I probably muted. Okay.
Anyway.
Can you hear me?
Yeah, we've got you.
Okay, so you can hear me, but I cannot mute. You have been muted by Ramon. Okay, Ramon, you can mute me. So Ramon.
Yeah, I'm sorry about that.
Maybe you can move Sanja. Anyway, Ramon?
Yes.
Okay, good. So you maybe try to mute that. It's a new system. We're still getting used to it. Not
Yeah,
big.
sorry about that. I think
No.
I was
It's
trying
not
to
you.
I was trying to mute her, and I think I mute everybody by her or him. Yeah.
Yeah. Anyway, so let's try to do it properly, and we'll probably learn things for the future. Sandra, can you? Oh, here.
I tried to mute, but then I ended up kicking them. So that's unfortunately.
No, this wasn't nice.
I know. I was trying. My finger slipped. I thought I was hitting mute, but I ended up kicking.
Yeah, I tried mute multiple times. It didn't work. Anyway, hopefully they can come back afterwards and mute themselves. I apologize. Anyway, let's go back to us to what we're discussing. And I'm not sure how interesting it is for the rest of our audience. So please jump in with questions. I'm asking them things that interest me, but it might be that something you're missing and may be helpful for you. So, for example, when you launch the cluster, does it have like a place that shows all the machines out there? Because if there is, then you can actually go ahead and SSH into your cluster and launch things like Dask SSH to deploy the Dask schedule and stuff like that. And do all nodes talk to each other? Like, do they all have permissions? How does it work?
I can kind of get into that. I mean, you can see that the nodes are all live in the AWS console. Yeah, let me share. I haven't shared. I'm not sharing yet. Yeah, let me go back to share in 1 second. 'Cause my screen was boring for a while, but now it's not boring anymore. Okay, so you can actually see the cluster master, the cluster head node right here. AWS again is still calling it master here. I don't like that terminology, but and then the 4 compute nodes that I asked it to spin up. So I can see each of these 4 nodes, and actually they've terminated now because they didn't have any work, and so after 10 minutes they turned themselves off, which is by design.
Okay.
And in this case, again, the cluster has just an IP address. I can SSH to it, and in this case, I'm actually where is my other window? That's what I've done here. I'm actually SSH'd into the head node here.
And can you see all the other nodes? Like, do they have names that you can actually go and this node recognizes them?
Yeah. So again, when the compute nodes were running, these were the actual host names of the 4 nodes that were running. So yes, I could SSH directly to them or ping them or do whatever I needed to do with them.
So you can, if you put this into a file, you can, and you have Dask installed, you can Dask -SSH, and it will deploy Dask SSH, and it will deploy a Dask cluster for you from the command line. You don't have to do anything fancy.
If you want to do it that way, there's no reason that you can't.
Okay, this is great. So it's like 2 commands, and you can only deploy a Dask cluster. One of them is P cluster. Of course, you have to go through the configuration, but once you configure it, the second one is Dask SSH, and then you essentially only have a cluster by 2 command lines. So it's a little bit more, but those are the 2 essentials.
Yeah. And there's an option on P cluster with version 2.1, I think, and that allow you to define a dashboard that would give you the same type of dashboard that you saw with Dask, but for P cluster. It's called dashboard. Let me put it on the group.
Yeah, this is a newer feature.
If you click on the if you click on the link that I put on the
in the chat, yeah,
in the chat, yeah.
Oh, it's the Cloudwatch dashboard. Yeah.
So it gives you it creates a dashboard by default for you, where it has information about your cluster. You know, how long they have been running, how much memory do they have, the CPU, and all that.
Right, and so that's in Amazon Cloudwatch. Yeah.
Okay, so this is how to monitor whatever is happening.
Mm-hmm.
Yes.
Okay.
Yeah. You can monitor it with the traditional tools like sinfo, right, which is going to give you the status of your nodes, right, and you can do SQ to see what's what's
this
running.
Is Slurm.
Yeah. This is in the case you are using a Slurm, right?
Right.
Okay. For people who are here who don't know, Slurm is one of the management systems. It's not exactly like Dask, but basically it's an older system that allows you to launch many jobs in parallel and monitor them and do other things with those.
Jacob, on the first part of this demonstration, Aaron showed how to launch the cluster with Jupyter Lab. And of course, it takes a little bit more because you have to deploy the Kubernetes and all that. And that is true that it takes a little bit more. But once you have that, creating clusters and launching worker nodes is as simple as writing a line of Python, or even actually, Aaron, if you go to the icon for Dask, to the plugin extension, there's even a way to do it, to create a new cluster right there. You know, with this.
It just created a cluster in one click, and it's got 4 cores on 4 workers, and it's there.
It's an extension that we use for this. Now, again, this is for people who are interested in using this Jupyter Lab as a base for their HPC or Dask. This is another option. But do you see, for your particular case, Jacob, do you see an advantage, or you really wanna go with pcluster because it's something that you already?
I'm just curious. Okay. I have 2 hats here. One of them, I need tools like this for my own work on disease modeling, but this is one thing, and I've been changing those every few years because things evolve.
Yeah.
And some things stopped working. That's like it's the world. But this is me. Here you have a community of 20 people trying to understand what we're talking about. So I'm trying to break it down. It's more important for me to show them the variety here. So perhaps you could summarize that there are multiple ways to go on the cloud, launch a cluster, and orchestrate all the things. So maybe we'll make some order, because my questions were confusing the people. Maybe you want to summarize the thing the way you see them.
Sorry. I
was going in my own direction because look, I'm stuck with Python too. I'm doing all sorts of things that are different than everyone else, and I need things a specific way. And you showed me a variety of tools now. So I looked at the first tool, I'm saying it, Dask Gateway, saying, whoa, it's cool. However, I have to now do Kubernetes and learn to actually go and do all of those things with Kubernetes behind it, and like go into the details and then launch it. That's a problem. Then you're showing me, no, the pcluster. You can do it in one command line. You can just pip install, launch the cluster. Of course, you have to configure, and you showed me how to configure. You said, oh, you can do this with this, then you can do it with that. So this is great. And then I'm showing, and you're telling me, oh, it will also deploy Slurm or Talk PBS or something for you. So I ask about Dask, and tell me, well, it's not exactly, but you can load whatever Python, whatever machine image you want that
exactly.
Dask.
Yes.
Of course, you have to launch it. So I was asking about how to do it, and you're telling me, oh, you can connect to the machine and actually do things, or launch things from outside, which is great.
And the learning curve, Jacob and team, is very minor once you start working with it, because the configuration files are very easy. So we have trained people, scientists at NASA, for instance, that their IT expertise was very minimal, and they have been able to launch clusters after a week of trying, or after a week of playing with it. They have been able to launch their own cluster, create different cluster configuration, even initialize compute nodes with additional parameters and additional software. So yeah, if you try, you're gonna see that it's not something that is very complicated to manage.
Okay. This is one of those things where at some point Ramon had really. He was really the driver for this particular implementation on our end. Getting Kubernetes stood up and getting Jupyter Lab and Jupyter Hub stood up, and he came to me and said, "Aaron, I need you to learn this because I don't have enough cycles to handle all of this myself." And so I dove in. I knew nothing about Kubernetes when I started. I knew nothing about how the Jupyter Hub or Jupyter Lab was deployed, and it didn't take me very long to get up to speed. Kubernetes is one of those things where you can go down a rabbit hole because there's 89 different ways to do. Again, there's so many different ways to accomplish what you want to accomplish. But the learning curve, once you figure it out, is good.
Oh, I see Sanjay's back. Sanjay, hi. Sorry, you were unmuted. We had to. We couldn't hear ourselves. Thank you for coming back.
Very sorry about that.
No, that's okay. That's okay. That happens. Anyway, so let's.
We have a question about what the problem space is that would require something like this.
Oh, what our scientists are doing with this distributed computing or with the parallel processing is a lot of work on data analysis, model analysis. The particular use case that comes to mind right now is a group that is looking at fires, looking at wildfire data, and doing a reanalysis of a lot of sensor data, from a couple of different orbital platforms. Of actual active fire data, and so they're trying to visualize some of this stuff, and it's a lot of number crunching that gets done in parallel. Anything beyond or outside data analysis, modeling. Again, if you're doing modeling, it's a lot of embarrassingly parallel stuff.
Actually, Aaron, I have used Dask also because you can parallelize any Python code. It doesn't have to be NumPy or Pandas. You can parallelize basically a loop. I actually have a process for that, as a matter of fact. Yeah. When we manage in one of our environments, we manage. My battery's running low, so I better go get my charger. We manage a number of environments in real time. Like in one case, we have a bunch of AWS accounts. We have like 50. Oh shoot, we have like 50 AWS. Knock off my headset here. Sorry about that. We have like 50 AWS accounts at once, and we have to run processes across all of them. So in this case, I can parallelize that so it runs the API calls to AWS in parallel. And that ends up being very helpful. Right. Like, for instance, we have for the security audits that we do, we need to create, for instance, to do penetration testing of the instances that we have on every account, on every region. So we need to run these reports that get the IP address from the instances, the security group, the ACL, which is like the virtual machine firewall and the perimeter firewall. And we need to get all those rules, and it takes forever if we do it, one process at a time. So we are using Dask for that. So not only for data processing, but also to run Python in parallel, for any different task.
Okay. I would like everyone who has questions so far, please jump in and ask them. Because we've been doing this demo for long, but we want to see some more interactivity. We want to see how much it actually was helpful for you. So jump in and ask questions so it will be more helpful for you. We want it to be as interactive as possible.
I have one quick thing to say, because I see that Tom is interested in NLP, and that's very interesting. We actually, Navteca just launched last summer an NLP product, the question answering system that is already implemented in NASA. And we are gonna also, there's a big social media company that is interested in the product. So just send me an email after that, because we're always using, we could use, anybody's help interested in NLP. So we're using NLP for this question answering system. I think it's something very interesting.
Okay, so guys, ask questions. This is for you. I can ask. I can send them in a local chat, and we can do it for my own things. But guys, they are here to show you something for the entire community. Use it. Use this resource. Please jump in. Ask questions. Don't be shy to ask basic questions.
Yes.
You can unmute yourself if you're trying to talk without muting.
I have a question. Is this integrated with an identity authentication service?
Yeah, we use for our particular implementation, we're using AWS Cognito as the IDP on the back end.
And just to be more specific on that, we use Cognito for the Jupyter Lab and Jupyter Hub web application. But for big cluster, it can be integrated with basically anything that you can put on a Linux system, right? So if your cluster is using Linux and you want to use any sort of LDAP or any other authentication system, it can be implemented.
Okay, now explain authentication system to all the rest of us, because the way I know to communicate the idea with the AWS is all those funny keys that you have to put in the correct folder and have this private key for public key. Please elaborate.
No, Cognito is a standalone identity provider that AWS provides as a managed service, and it's specifically designed for web applications, like we have implemented with Jupyter Lab. So it's username and password, and it does multi-factor authentication out of the box. So you can use text messaging as your MFA, or you can use one-time codes, using an app on your phone. But that's what we use for that. But again, Ramon was. So it doesn't have anything to do with the AWS console process using API keys or anything like that. So it's a different animal. Cognito is its own product that's specifically designed for integration with any SAML-aware web application.
You'll still need those private key and public key for your AWS account to actually go and launch the Speak cluster and launch all those things, correct?
You would need to operate either from an AWS instance inside your environment with the proper permissions attached to the instance, which is the way we prefer to do it, because we don't like API keys. We like to avoid API keys as often as we can.
Yeah, so. But Jacob, again, yes, you can. If you're gonna install Peak cluster in your local computer, then you will have to install the share key and the private key. At NASA and other enterprises, because we have to follow some security or best practice, what we do is we use a Bastion server, and that Bastion server has what is called a role, an IAM role attached to it. And the IAM role has the policy that allow it to create clusters, things like that.
Yeah.
So there are the multiple way of doing it. We try not to use private key and share key because of the security requirement.
Yeah, but people who will be doing it here and trying to learn something new, this is the way they'll have to define it, because they'll have to create the private and public key, and then get the AWS account credentials inside, probably in the configuration file in the AWS P cluster that you showed us. This is how they probably are going to do this, unless you're in a big organization, in which case you have different. You'll have to ask your organization people. This is why we're asking those questions. It's like, and what you said before is the web service. It's a different authentication only for the web. Only for the web server you did with a Dusk gateway before, correct?
Right.
The specific authentication server.
Right. If you are using the Jupyter Lab, which at the end of the day, Jupyter Lab is a web application, right? It's a web application where you can run Python, R, or any other language interactively on the web. So for that, if you are going to run the Dusk cluster using Jupyter Lab, your authentication happens when you log into the application, and we use Cognito for that. It is possible to connect Cognito to your Linux PAM system, PAM or PAM. I don't know what they call it.
Pluggable Authentication Manager.
Yeah, so it is possible to do that, or you can just use, if you're going to be using P cluster, you can just use SSH keys, or you can connect your instances to an LDAP or whatever you want.
Yeah. Now it's all understood how the things that you explained before. Any more questions? Please. They talked for an hour, showed many things. Some of those things have probably gotten to you, and there's a missing piece somewhere. I know I have several missing pieces, but I want other people to tell what their missing pieces are. Or ask, because asking here will help you understand. Unmute yourself if you want to ask a question. If you're shy, put it on the put it in the chat, and Silas will help. Okay. Apparently, there are no more questions.
There are no. There's a question. Where do you find recordings of the meetings?
I'll put them on the same. I'll put the link later. It's on my YouTube channel. It should be on the Python meetup one, but I just started putting it in my own channel a while ago, so it's still there. I'll post the channel later on in the chat. Thank you for the question, and you can go back to this recording. Yes.
Sandhya just asked a question that's near and dear to my heart, and the short answer is yes. In our particular,
can you read the question?
Is there some way to load a predefined Conda environment when Jupyter is fired up? And the answer to that question is absolutely yes. And it depends on your implementation of Jupyter Hub and how you've laid it out. In our particular case,
can you show that, Aaron?
I can do that. Give me 1 second. In our particular case, because we work in a containerized environment on top of Kubernetes, we build all of that directly into the container image that we launch. And I want to go over here and let's get out of here. No, not in there. We can do it in here. I can do a Conda env and list. And so the default Conda environment on this machine is this one called Notebook. And so if I do Conda activate notebook and Conda list, you'll see that this is an extensive, this list is going to go on like a bunch of screens because we tried to come up with an environment. We have 3 side-by-side projects that are running right now. Yes.
But one thing that, if you go back to the launcher, one thing that is important to mention is Jupyter. One of the main goals of Jupyter Hub is to be able to provide the scientists or the users with standard environments. So you have the default environment, but as you can see here, where you see Python Conda SMC admin, you can also create your own Conda environment. And instead, on a notebook, instead of using the default environment, you can use your own custom environment where you have installed your own packages. You want to show one of the notebooks, Aaron, and you see how you can easily change from Conda environment to Conda environment?
Sure. So here, you know, when you're in here, this is how you select the kernel, and it's saying it's using the default Python 3 kernel. But here, if I want to use this, like I have one that's got TensorFlow in it, so I'm going to select that TensorFlow environment, and it should, yeah, there we go. That Conda environment comes up right away, and so now it's running inside that particular Conda environment. So
Aaron was saying kernel, but basically kernel is kind of like the way Jupyter Lab understands about Conda environment. So it's similar to a Conda environment. Right.
And because Jupyter is designed for a multitude of programming languages, right? Jupyter stands for Julia, Python, and R. And again, we've kind of shoehorned Fortran into this because the scientists wanted it. That's why they use the word kernel, because you can conceivably go from one language to a completely different language.
Yeah, you can run R. In fact, I think there are many kernels in the community. I think people are running C, C++, and all sort of things.
Yeah.
Yes, she's asking can I save and share my notebook? Absolutely. In all these files that you see on the left that have that orange icon, those are notebooks that you can just email to anybody. The cool thing is on this platform that we have created, if you go to the Git extension, Aaron, you can also connect this to any Git repository and share your notebooks using Git. So there are many ways that you can share it. In fact, if you go to the second icon, that one that looks like a bucket, that icon allows you to. This is an S3 bucket, so you can even upload them to an S3 bucket and share your notebook that way. Notebooks can be shared with any other user, and the users can go through the notebook and run the different cells.
And again, the beauty of the beauty of Jupyter Notebooks as a whole is the ability to not only run these code blocks, but actually insert Markdown as well, so you can lay out what's going on. So I've got notes in here saying, don't forget to scale your cluster, right? So and yes, it's infinitely shareable. This particular example, this DAS gateway example that I gave you, which again theoretically is only going to run on a Jupyter Hub that has DAS gateway installed on it, is available in the GitHub that I showed. So you can, it's literally a portable file.
And if you want more examples of notebooks, I mean, the whole scientific community is using notebooks to do the research and to share the research. So you, for instance, if you do NASA notebooks, you're going to see plenty of notebooks that you can download, and you can see maybe notebooks about CO2 research, or the notebooks about the fires that Aaron was talking about. All those are public. You can download them, and you will see not only the code, but you also see visualizations, right? GIS visualization. You will see dashboard of different data sets.
One of the nice things about some of these too, I'll actually show, like this. I've got this particular library, I think, is that it can do neat things, just like, I have it throwing a map up here, and it's interactive, and I can plot things on this map using Python code. That's all I've done here. Granted, I focused it on where I live, which is nice, but it's, just very basic things like that. Any Python library that can do visualizations like this, you can do this stuff in real time, in line in your notebook. The uses are almost limitless. So,
yeah. Okay. Any more questions before we can have more questions after we stop the recording, but like for now, any more questions? People want to be recorded and with an answer?
We had a question about how to save and share the notebook, and then if someone can post the repo that has it handy, a link to it.
Yeah, I'll post the one GitHub repo that I've got that's got both the DAS gateway example notebook and the parallel cluster configuration. I will drop that right here in the chat. Those are just the two quick ones that I showed tonight.
And I pasted my contact information again. If you guys have any questions about any of the topics that we talk about today, please feel free to ask. We'd like to share, everything that we're doing, anything we can do to help the Python community. We're all for that. NASA is very, they are heavy users of Python.
Okay, but you represent Navteca, correct? It's like...
I represent Navteca. Yeah, I'm the CTO and co-founder of Navteca, but I've been working on NASA project for a long time. So
okay, so it's important because sometimes it becomes blurry. So it's like we want to make sure that people understand you're a private company that
we're a private company.
That does contacts,
Yes, we're a private company. We are a government contractor. We work for NASA and for NOAA. We try to help the scientific community with technology innovation, like machine learning, cloud, HPC in the cloud, and things like that.
Okay, so it's important to say this because it's important to make the separation here for everyone to understand.
Absolutely, yes.
Yeah, we do not speak for the agency.
No, we don't speak for the agency.
I was making sure that this is like...
Yes, we don't speak for the agency.
I had your back, guys.
Okay, thank you so much.
I know what it means.
Yes.
More questions, guys? Anyone from the audience? And you can actually speak up. You don't have to be shy and write it out. But if you're shy, Silas will read it for you. Okay. I see. It's either quiet or I always make sure that my Wi-Fi is working. Okay, so it seems that there are no questions. So in that case, I do want you all to make noise and thank you. Please make noise and thank you, our presenters, both from all mirrors and
thank you.
It's been wonderful. It's just to tell you, this is a good one. Hey, I like it. Hey, how do you do this? Yeah, clap. Oh yeah. Okay. Now I know how you do this. Oh, you see, now you're getting there.
Now it's a party. Yeah.
That's kind of cool. Yes.
Yeah. Okay, guys, thank you so much for this. I wasn't sure that there'll be an even Python coding this month, but you guys not only presented a good topic, you came in no time to present it. So I personally thank you so much. And stick around. I'm going to just stop the recording, and it's going to stop recording or something like this. A minute. Here we go. Stop recording.